IETF got into the act and said that, look, we have so many different protocols. Microsoft has their own and somebody else has their own and version of everything. So why don't we design an extensible authentication protocol? A protocol, once it is done forever. And so that is called EAP. And the advantage of EAP is that the NAS, the access point, doesn't need to know anything other than EAP. And then you can use Microsoft's CHAP or you can use anything else on the top of EAP. So EAP is Extensible Authentication Protocol. And it was initially developed for point-to-point protocol, PPP. Where do you use PPP? DSL, right? When you try to connect to your carrier, it's a point-to-point line, and the protocol on the top of that is PPP, right? And so it was developed for PPP, and it is very simple protocol. It has a window size of 1. Window size of 1 means start-stop flow control, right? Only one packet is in the flight. So you send a packet, wait for the response, send a packet, wait for the response, send a packet, wait for the response. You cannot send 3 packets at a time, or any number of packets at a time. Only one packet in flight, duplicate, elimination, and retransmission. So because packets have a number, if you get it again, then you know that they are duplicate. If you don't get the response, then you retransmit. And ACK or NAC, both are allowed, so you can run over lossy links. It does not allow any fragmentation, and so that means each message has to be small enough. Individual authentication method can deal with fragmentation. If your method requires big messages, like if you're doing public key or something, and you need 1024, byte long something, right? Then you deal with your own fragmentation. Right? So higher layers have to deal with that. And since EAP will do only one fragment at a time, one round trip, it might need many more round trips. Allows using back-end authentication server, which is basically we talked about. And so the authenticator does not have to know all the authentication methods. So now we are using the name Authenticator. So there is a user, and that is actually called supplicant. Okay, I'm going to use that word in the next slide. It's not on this slide. So there is an applicant which is called supplicant. Okay, so the user who is really trying to get authenticated is the supplicant. Authenticator is the guy who it is connected to, and authentication server is who has all the data. So authenticator does not have to know all the authentication methods. So authenticator does not know that you're using TLS or using AES or using this and that. It doesn't have to worry about any of that. And it can run on any link layer, PPP, 802, and does not require IP. So the thing is, this is basically a layer 2 protocol, and so it does not require IP. And there are many, many versions of EAP, as you will see in a minute. Here is the word supplicant. This is the entity that is trying to authenticate, and that is called a supplicant. This is the authenticator, which might be the base station as shown here, and this is the authentication server, and it has the database. If this is not there, then you can put the database right here, and the EAP will run between these two, right? So EAP is spoken between these two. Then master session key, keying material agreed by the peer and the EAP server. So during this negotiation, they can also get a key, and once that key is established, which is at least 64 byte, it says 64 byte, I think that's too long. I think it should be 64 bit. This is at least, in general you might have longer than 64 bit, but 64 byte would be just too long. Because we are going to see in a minute, not in a minute, in the next chapter, when we talk about wireless, they use 128 bit. So that will not be allowed by this if we put 64 byte. So 64 bit keys could be used between these. And so anyway, so the EAP, the messages again are very similar to Radius and very simple. Basically the messages start with a code and then an identifier, which is a sequence number, a length, then a type, and a data. there are two words here, code and type. So the code is basically tells whether this is one of these request response success or failure, and the type indicates the higher level which protocol whatever is running. So it could be, for example, this is a SHA message, and then it will give into this SHA module. So this is for what we call basically higher layer multiplexing. So next slide actually talks about the different types, but let's just see what else is on this slide. So there are only 4 message codes: request, response, success, and failure. And as you can see, this is just a 2-point protocol, a link level protocol. So basically, as opposed to radius where you had people in the background, here it is not really required. You just speak EAP, and so a request can go and a response can come, and then the success and failure. So the identifier is the sequence number, and then the length of the data, and so on and so forth, and the inside the data is this type. A type field in the request response indicates the authentication method, assigned by the IANA. So basically anything that you want to do on the internet, you need a standard number, say port 80. You want to reserve it for HTTP, right? So no other protocol will use port 80. How do you do it? You go to IANA, and the IANA makes a note in a RFC that port 80 is reserved for HTTP. In the first 20 years of internet, IETF, or maybe first 40 or 30 years of IETF or internet, it was a person. IANA was a person, somebody at UCLA. So anybody who went and said, I want this, okay, so he will think about it and they will give it to you. And then other countries started complaining. How can you have such a control, such a powerful position, with just one person? And that person actually started with, when the internet was 4 nodes, one of the original people, right, John Postel. So the United States government immediately set up this IANA. Well, they set up a US-based organization which acted like this. So instead of a person, now it became an organization, US organization, which had complete control. Then the countries still complained, so now it is an international organization under the UN, where if you want something, you go to that IANA and then they give it to you. So anyway, so these basically all it is so that people don't have different numbers for different things, for the same thing. And so all the standard numbers are put into this RFC, which is I think called standard numbers, I think, something like that anyway. And so whenever you need any constant in the internet, you go to IANA, get that constant, and then put that into that RFC. The type fields indicate the authentication method. So for example, if you want to indicate that I want to use AES, there is a type field number 5 or 6 or whatever number is assigned for that type. Okay? So then you know that this message is for AES module, higher layer module. Similarly, when you do TCP port, now I've already got TCP port numbers. What else? Any layer. Basically, say for example, on the Ethernet, there is a protocol type field, and it tells you whether it is IP or something else. It has to be standardized by somebody, right? In the case of Ethernet, although it is not, I think in the case of Ethernet, it is IEEE which will standardize it, and then IEEE means ISO, so that is not under IANA. But anything layer 3 and above is IANA. So the way it works is that you can have many authentication methods, method X, method Y. You could have, let's say we are talking about hashes, and we are talking about MD5, SHA-1, and something else. So they are all different methods. So there are 3 layers in each. First is what is called authentication layer, second is the EAP layer, and the third is the lower layer. Now lower layer actually not part of EAP. Lower layer could be Ethernet or something like that, whatever it runs on. or PPP. Now, EAP layer basically has that message format that we showed, and then peer layer and authentication layer, this is the layer that runs in the supplicant, and this is the layer that runs in the authenticator. So this is somewhat asymmetric. And then they will have the methods. So this one generally requests things, and this one generally responds to those requests, right? So this is the supplicant, and this is the authenticator. And then you can build any methods. The number of methods is not limited. That is why it is called Extensible Authentication Protocol, EAP. So you could tomorrow discover elliptic cryptography, and you could get a code from IANA for that type, and then you can use that method here. All right? So EAP methods are not fixed. The list keeps going. Now the EAP layer, this layer, basically uses those codes, and code 1 means request, 3 means success, 4 means failure. So those 1, 3, and 4 are given to the peer, and 2 is given to the authentication layer. Okay, so all the responses are given here, and all the request, success, and failure start from here and given to there. Responses start from there and given to here. Both ends may implement peer layer for mutual authentication. So if you want to authenticate both sides, you would just do it both sides, same thing. Lower layer may be unreliable, but it must provide error detection. So error control is not required, the transmission is not required, but detection is required. And it should support 1020 bytes or longer, because then it doesn't fragment anything, remember? It doesn't fragment, so everything has to be in one message, and it should not be so small that it cannot put those things in one message. You could have a mode where the authenticator simply acts like a gateway, just like we saw it in the radius case, where the server was remote, and it was going through the authenticator, where it was simply passing it on. So in this case, whatever comes from here, so this is actually request, I mean this would be response. A request will go the other way around. So this one just simply acts as a pass-through for request and responses. You see it has authenticator here both, and then the peer here. So this one goes that way, and so peer talks to the authenticator. So this is actually, okay, I'm sorry, this is what they're talking about here. There are two EAP connections here. One is between these two, and one is between these two, right? And now this one is using AAA and IP. AAA means radius and IP. So this EAP message is encapsulated into radius and then sent over IP, or actually UDP. So this is that backend session, and in that case, basically we saw that without seeing this detail, that this is just passed on to the user, all the responses and so basically the type field is used here, only here, and the code field is used here. This one only knows the code, which is 1, 2, 3, 4, and doesn't really need to know MD5, SHA-1 and all that. But these people have to know MD5 and SHA-1. So the type field is used there at the end-to-end type field, and the code field is used in the middle. So what are the protocols that can run on the top of EAP? A lightweight EAP, which uses Microsoft Challenge Handshake Protocol, TLS, TTLS, which is tunneled TLS. Then there is basically, I mean, these are all the details that actually we don't have time to go into this, but basically, and this is the, so in TLS, both sides need certificate. In tunnel TLS, only server needs the certificate, and then there is a fast, flexible authentication by secure tunneling. Certificates are optional, somehow in some protected tunnels. Then PEEP, which is the protected EAP, where the servers have certificates, clients have password. So here, basically the list is many vendors and many situations required many of these top level protocols. So they have this whole list here, and the list is not complete because obviously we cannot put all of them in one place, but this is some of the common ones here. So for example, EAP-SIM is used in the SIMs that you use in your phone, SIM cards. The SIM cards use EAP-SIM. Subscriber identity module is your SIM card in GSM, 64-bit keys. And then authentication and key agreement, AKA, used in 3G, uses 128-bit. Pre-shared key and AS128 is used to generate the keys. And IKE is the Internet Key Exchange with mutual authentication, certificate, password, etc., IKE is used. So there's a whole set of things basically which are used on the top of EAP. One of the things on the list is the security token. EAP is a security token. What is a security token? Security token is a device that you carry with you like this. It can generate the responses. So for example, a request may come in if you are using the security token protocol on the top of EAP, it may come in, please tell me what is the next sequence number. Then you look up into your equipment and it tells you the number, you put that number in. And or they might have their own Bluetooth interface, so you don't have to type it, you just press a button and the message is sent to cell phones or to your computer, a laptop or a USB, whatever. Or you could have a smart card inside your phone. So basically this provides two-factor authentication because this includes what you know, like your password, and what you have, like this device. If you lose the device, nobody can use it because they don't know the password, and you cannot obviously get authenticated unless you get another device. I don't know how many people use it where, but I know one of my friends who works for RSA Incorporated, he carries this kind of thing with him everywhere. So for RSA, you can't work without these devices. And they probably sell these devices anyway. So there is an algorithm which is executed in the host and the server, and the same algorithm is executed here. If the response comes out the same, it's basically a simple computer, simple calculator. So suppose they send you a challenge and saying, that, okay, what is this? You just do some hash or something, right? And you respond back. So it's exactly the same thing that we could have done on the computer. So there are two ways actually. So some are based upon the time. So some are based upon time, some are based upon the challenge, some things like that. And some are just based upon the count. So every time you press the button, the count increases and then it sends the response. So if your previous response was logged and that was response number 1000, now this time it is 1001, it cannot be 1000, 2000, because obviously, it can be 1001, maybe one or two are missing, right? So there are many ways to get to the next response. And in fact, that might be in the next slide. So one-time password is something that can be generated by one of those devices. And there are three different kinds. One that use some kind of algorithm to generate a new password based upon the previous password. And some use time to generate a password. But that will require synchronized time. So you could not be very far off in your clock. So, for example, if you just use hours and minutes, so you cannot be more than 1 minute off. Some use a math algorithm based upon the challenge. I think we talked about all these three things, right? So basically, it could be a challenge that is just hashed and sent back. It could be that you just take the time, or it could be just basically something to do with what did you do last time, which could be your previous password, or previous count, or previous something. So time synchronized approach allows users to generate password and not use it. Okay? And that's the advantage of the second one as opposed to the first one. Where if you don't use too many of these, then you may get out of sync. The server is expecting 1001, 1002, 1003, and you are sending 2000. So the server may compare to the next, and passwords allow for missynchronization. And the non-time synchronized one-time password do not need to be powered at all time. Battery lasts long and have been attacked by phishing. Time-based OTP need to be used right away. Yes, the thing is, if you are generating something from the time, then there is a limit within which you have to use it, because otherwise the time is passed and the new time has come in and you have to put a new time. But so the other ones which don't use the time, they can be turned off, and they can, so that they have been attacked by phishing. And we know what phishing is. Phishing is basically somebody asking you for a password and you just generate the password. And even though it is one time, but you might use maybe many of these and then you may get out of sync. So moving on, before I move on from EAP, is this making sense so far? First we saw Radius, which was long distance IP based 2-hop process. Then we saw EAP, which is basically protocol for two nodes to talk to each other. And they have very similar concepts, only 4 messages or 5 messages codes, and the authenticator in the best case only needs to know those 4 and doesn't need to know about the higher layer protocols. So then the question is, how do we use EAP? It was designed for PPP. So how do we use it over LAN? So then there is a version called EAPOL, which is EAP over LAN. EAP over LAN basically is designed for working over IEEE 802, which is basically Ethernet. So what you do is you take the EAP proto packet and put it in the Ethernet. And the Ethernet packets actually start with the Ethernet header. Then they have Ethernet version. So this must be EAP version. So Ethernet header has the source address, destination address, protocol type. What I wanted to say was that in that protocol type field, one number has been assigned for EAPOL. All right. So once that protocol type comes in, then you know that inside this whole thing is EAPOL, starting from here. So the first byte in EAPOL is version number, then comes the type, and there are 5 types: start packet, key packet, EAPOL packet, log off, and alert. That comes here, and then you get the length and then the body. So when we talk about EAPOL packets, the lot of packets that we'll see, they will say EAPOL key. EAPOL key contains the encryption and other keys sent by the authenticator to the supplicant. EAPOL packet contains EAP messages, which are the 4 messages: request, response, success, and failure. So that will happen here. In the packet body, you will have 0, 1, 2, 3, 4. The first field was code field, that will happen here. And if it is a log off, then obviously that will be type indication, and if it is an alert, then the type indication. So it's little confusing because there are now type is happening in 2 different places. This is this EAPOL type, and then there is a code, and then there is a type inside, right? And that type inside is for what? In EAP, we had 2 things, code and type. What was code for? Yeah, 4 messages, right? EAP messages. And the type was for what? That was the higher level protocol that you're using. So that is also there, right here. So here is the EAP message. From here onwards is the EAP message. But they have added to the EAP 3 fields. They have added 3 fields. One which is length, second is the type, and I don't know why they added the length, because I thought there was a length here as well. Then they have a type field and the version number. Version is always supposed to be 1 anyway, and then the type is one of these 5 types. So this one actually is session oriented or connection oriented, if you want to call it, because for that session they agree upon a key. And that key is used until you log off. So this EAPOL, now all of this, by the way, we will use in the wireless session lecture. That is what I want to give. And in the book, chapter 17 is wireless, and they use EAPOL, they use EAP, they use 802.1x without explaining in detail what is all this. So I felt that we need to explain all this first before we get into the wireless chapter. Okay? So it's important that you understand this part, that the book doesn't have enough about any of this. Alright, so EAPOL is EAP over LAN, and what it does is it takes the EAP packets and puts this 3 field header and puts inside the Ethernet header. At least that much concept is clear, right? And then everything, as I said, you have to read it in the Wikipedia. All right, the last thing. The last protocol that we need in terms of authentication is what is called 802.1x. Now, 802.1x was invented because we had Ethernet ports all over the buildings, everywhere, and anybody could come and connect. Right? You can go to any company, you're having the meeting room, and then you put your computer into their wired infrastructure, and you get connected to the network. It's not very safe. So how do we stop people, our guests, our attackers from connecting to our network? They designed 802.1x for that. And by the way the 802 protocols are numbered, and this is something that we teach in 473, is that 802 has many numbers, like 1, 2, 3, 4, 5, 6, 17, 18, 19, now I think they are up to 24 or something. 802.3 is Ethernet, right? That you should know by heart. And 802.11 is Wi-Fi. So those two protocol numbers you remember. So the thing is, all 802 protocols follow 802.1. 802.1 is common to all the 802 protocols. Okay, so 11 and 3, both of them will follow 1. So 1 then has A, B, C, D, 1A, 1B, 1C, 1D. Some of them are uppercase, some of them are lowercase. But 802.1x with the x in the uppercase. So this is mechanism for all 802 protocols. Just not wired Ethernet, it is also for the wireless, which is Wi-Fi. What is the mechanism? The mechanism says that all external port will normally be in this mode, where when somebody comes in, only thing they can connect to is the authenticator and not the rest of the network. The switch is open, right? Until you authenticate, you cannot connect to the internal network. Once you have authenticated, then the authenticator gets out of your way, and you can now use the internal network without any problem. So everybody understand the purpose of 802.1x. Now we are going to go to see the messages. But before we go to the messages, the idea is that the Ethernet ports are no longer always connecting. So when you buy an 802.1x supporting switch, all right, you generally don't have it at home, but you will have it in the office. If you have a 802.1x switch, a switch that supports 802.1x, when you connect, you don't get automatically connected to the rest of the network. You have to somehow authenticate that this is a valid connection. So if you work for a company and you need to connect obviously you need to wire the building, you need an 802.1x supporting switch, so that any guest, anybody else cannot just connect their computer. Alright, so let's see what the messages are. Okay, the messages are basically, they use the EAPOL, or EAPOL in this case, because this is generally Ethernet. If it is Ethernet, then it is EAPOL. If it was something else, then it will be EAP. So even though I may say EAP here, it may be EAPOL, okay? So the station comes in, and whether it is wireless or Ethernet, is the same set of messages. It says, can I connect, please? And that is called, may I associate? So that is called the associate message. Particularly in the wireless, you associate with the access point, right? So the access point is your authenticator. And the authentication server is here, which is different from authenticator. You are the supplicant. So you send an associate message. It says, please send me your request, send me your identity. You send your identity. It says, here is the authentication request. You send the authentication response, and then it says success. Once the success message is seen by this port or this access point, then it connects you. Now, it is quite possible that you can put the authentication server with the access point, but you will not. Why not? Particularly in the wireless environment. Access points are everywhere. Okay, in this room there might be 2 or 3 access points. Right? People can steal them. Right? So you don't want to keep any secrets there. So all the secrets are kept somewhere in a locked building. And the ports use PEEP, EAP, radius, whatever is required to communicate, right? But your access point, if it is 802.1x enabled, so you look at the features supported by the access point, it will say 802.1x. That means it will understand this and will be able to authenticate the users. So these are enterprise class switches, as we call it, enterprise class access points, as opposed to the residential class where all these features are not supported. All right. So authentication method can be changed without upgrading the access points and the switches. Only the clients and the authentication server need to implement the authentication method. So whether you are using AES, MD5, whatever else, those only go in these two places. Access point simply knows this message, EAP success. As soon as it sees a EAP success coming from this side, which is protected side, it believes it and gives you the connection. All right, that brings us to the end of this module. This chapter, actually, if you want to call it a chapter, not a chapter in the book, is that the radius allows centralized authentication. And actually radius is really worldwide in the sense that it runs on IP, TCP, UDP, and so actually not TCP, UDP. So people do use it for authentication in different countries from different countries. Okay, so when you do ISP roaming, that is what they're using. They're using a radius. EAP is a protocol that allows many authentication methods. So they got tired of CHAPS, and PAP, and similar authentication methods. And everybody had a different authentication method, and they were changing every day. So they said, let's design one protocol where the only thing they need to know is the code. So that code is the standard code. I forget the number, 3 or 4 means success. Period. Right. So that is EAP. And then the EAP runs on Ethernet, and that version is called EAPOL. And then on all 802 protocol, you can have 802.1x, which ensures that people coming in are not connected automatically until they're authenticated. 4 things. We learned radius, EAP, EAPOL, if you want to call EAP and EAPOL, and then 802.1x. This homework, but I would recommend that you do it. How would you implement Kerberos v4 over EAP? So you really want to run Kerberos v4 on the top of EAP protocol stack that we saw in a LAN environment. So the sequence of EAP messages that will be sent for authentication and key generation, so also EAPOL headers on the messages. So basically we are assuming that the EAP is on the Ethernet. On the top of EAP we have Kerberos 4. Now Kerberos 4 has 6 messages, which are in some slide somewhere. So you just need to show those 6 messages plus whatever else you need to show, for EAPOL or EAP. Okay, so this is that homework.